All right, you are welcome. Again, let's see what we have for today. Without using table or calculator, find the value of cos 15 degrees, sine 105 degrees, and tan 75 degrees. Yes, we want to find the true value of cos 15 degrees, sine 105 degrees, and tan 75 degrees. When you bring your calculator and you punch cos 15 degrees, it's going to give you root 6 plus root 2 all over 4. Yes, that is what they're going to give you. So, but we are asked to solve for it without using calculator or without using table. So, what can we do so that we will find the true value of cos 15 degrees, which will give us root 6 plus root 2 all over 4. And then when you search for sine 105 degrees, it's going to give you root 6 plus 2 all over 4. You get it? Yes. So the question is, how is it being solved that this value is obtained? That is what we're going to do. And then when you say tan 75 degrees, it's going to give you 2 plus root 3. Hello? Yes, punch in your calculator. Tan 75 degrees. It's going to give you 2 plus root 3 degrees. So the question is, how is it being solved that it gives this value? So, and we are asked to solve it without using calculator or without using any table. So please pay attention to this lesson. It's very, very important. Pay attention, most especially tan 75 degrees, because we employ some logics in the solvings. You get it? Please pay attention. It's very simple and it's very, very important. Now let's go. In one of our lessons, we talked about trigonometric ratio of some special angles, and then we solve on how to find some special angle. Is that true? Yes. We're going to make use of some vital information from that lesson. Okay? Now let's go from that lesson. I want you to draw on your rough book or anywhere, draw two shapes: right angle triangle and then equilateral triangle. And then in the right angle triangle, this is how it's going to look like. We're going to have the two sides to be 1, 1, and then root 2. And then we have angle 45 degrees. One of the angle 45 degrees. And then we have in equilateral triangle, all the sides to be 2, 2. Then we have base side to be 1, 1, which is the same as 2. And then we have angle 60, angle 30, and then the center line should be root 3. Okay? So this shape is very easy to draw. Okay, I just want you to get it. It's very simple to draw. Now from this place, we are asked to solve for 15 degrees, and then in one of our lessons we solved for some special angles, and then we did not solve for 15 degrees, but we solved for 30, we solved for 45, and we solved for 60. So what we're going to do here is this. We're going to ask ourselves a question. What can we do with these angles that we have? That is angle 30 degree, angle 45 degree, angle 60 degree. What can we do with these angles so that we obtain 15 degrees? You discover that when you say 45 degrees minus 30 degrees, it's going to give you 15 degrees. You get it? Yes. That means we are going to make use of cos 45 degrees minus 30 degrees. Hello. So you discover that cos 15 degrees is the same as cos 45 degrees minus 30 degrees. So you discover that in one of our lessons, we talk about trigonometric ratio of multiple angles. we proved some theories, one of which is we say that cos A minus B is equal to cos A cos B plus sin A sin B. Yes, please, if you have not watched that lesson, please, I want you to do so. It's very important. We say that cos A minus B is equal to cos A cos B plus sin A sin B. You get it? Now, you discover that this cos 45 degrees minus 30 degrees is the same as saying cos A minus B. You get it? Yes. Now, in this place, let's take 45 degrees to be our A and then 30 degrees to be our B. Okay? Now, let's go. That means we're going to have in this cos A cos B plus sin A sin B, where we have our A to be 45 degrees, our B to be 30 degrees. That means we're going to say that cos 15 degrees is equal to cos 45 degrees minus 30 degrees, which is equal to cos 45 degrees cos 30 degrees plus sin 45 degrees sin 30 degrees. Hello. Please pay attention to this. It's very important and don't be confused. If you have any question, please, you can forward it to my email, okay? Now, let's go. We say that cos 45 degrees minus 30 degrees is equal to 15 degrees. Is that not true? And then we say that for us to solve it, we are going to employ this formula that says that cos A minus B is equal to cos A cos B plus sin A sin B. Let us call 45 degree A and then 30 degree to be what? B. Then when we replace it, we're going to have cos 45 degrees cos 30 degrees plus sin 45 degrees sin 30 degrees. Okay? Good. Now let's go. We're going to check for cos 45 degrees. So what do we say that cos 45 degree is? Now let's look at this, our shape here. You get it? Now this right angle triangle. Now from here, you can figure out that cos 45 degrees is going to give us adjacent all over hypotenuse. And then adjacent is 1, and then hypotenuse is root 2. And then sine 45 degrees is the same. So we have 1 all over root 2. Okay? Then let's also find cos 30 degrees. So cos 30 degrees, let's make use of this shape. So this shape, we're going to see that cos 30 degrees is equal to root 3 all over 2. You know, we have adjacent all over hypotenuse. So our adjacent here is root 3, then an hypotenuse is 2. So we have root 3 all over 2. Then when we say sine 30 degrees, we're going to have 1 all over 2. Okay? So in this place that we're having cos 45 degrees times cos 30 degrees plus sine 45 degrees times sine 30 degrees. So in this place, we have found our values for cos 45 degrees, sine 45 degrees, sine 30 degrees, and then cos 30 degrees. Now let's fix them. So we're going to say that cos 15 degrees is equal to cos 45 degrees minus 30 degrees, which is equal to, we have cos 45 degrees cos 30 degrees plus sine 45 degrees sine 30 degrees. So we have our cos 45 degrees to be 1 all over root 2. Then we say times our cos 30 degree. Cos 30 degree is root 3 all over 2. Now let's place these two terms in bracket. Okay? Then we say plus. We have sine 45 degree. As 45 degree is 1 all over root 2 times sine 30 degree is 1 all over 2. Okay? Now let's go. Let's also place this in bracket. So in the first side, we have 1 all over root 2 times root 3 all over 2. So let's multiply. 1 times root 3 is root 3. And then root 2 times 2 is going to give you 2 root 2. Then we have plus the other side. 1 times 1 is going to give us 1. And then root 2 times 2 is going to give you 2 root 2. Okay? Yes. Now we are having root 3 all over 2 root 2 plus 1 all over 2 root 2. Yes. In this place now, let's combine them, or let's just add them together. Okay? So when you add them together, we're going to look for the LCM. LCM is simply 2 root 2. So 2 root 2 divided by 2 root 2 is going to give you 1. 1 times root 3 is equal to root 3. Then plus 2 root 2 divided by 2 root 2 is equal to 1. 1 times 1 is 1. So therefore, we're going to have root 3 plus 1 all over 2 root 2. Hello. So we have cos 15 degrees to be root 3 plus 1 all over 2 root 2. Pay attention. We are yet to conclude. We are yet to finish it. Okay. So what we're going to do here is we want to remove this root 2 in our denominator. So for us to remove it, we are going to do what we call rationalization. We're going to do what we call rationalization. Okay. So we are going to simply multiply the numerator and the denominator by this root 2. Okay, that is called rationalization. Now let's go. We're going to say root 3 plus 1 all over 2 root 2 times root 2 all over root 2. So, but you discover that root 2 all over root 2 is what? Is equal to 1. So 1 times our expression, it remains the same. Hello, is that not true? Yes. Now let's go. So when you say root 3 plus 1 all over 2 root 2 times root 2 all over root 2, let's multiply. So in our numerator, we are simply going to have root 2, open bracket, root 3 plus 1, close the bracket, all over. So when you say 2 root 2 times root 2, it's simply going to say root 2 times root 2 is going to give you 2. So 2 times 2 is going to give you 4. So therefore, our denominator is going to give us 4. Now in our numerator, let's open the bracket. So we're going to use root 2 to open the bracket. So when you say root 2 times root 3, it's going to give you root 6. Then when you say root 2 times 1, it's going to give you root 2. Then we have all over 4. So therefore, cos 15 degrees is equal to root 6 plus root 2 all over 4. Hello? Yes. Now let's go. Number 2. We say sine 105 degrees. So what can we do to find this sine 105 degrees? So when we think very well, discover that when you say 60 plus 45 degrees, it's going to give us 105. Is that true? 60 plus 45 degrees is going to give us 105. That means we are going to simply say that sine 105 degrees is equal to sine 60 degrees plus 45 degrees. Yes, 60 degrees plus 45 degrees is equal to 105. And then in one of our lessons, we talked about trigonometric ratio of multiple angle. So in that lesson, we say that sine A plus B is equal to sine A cos B plus cos A sine B. And then in this case now, we can take 60 to be A and then 45 to be B. So if you do so, that means we're going to say that sine 105 degrees is equal to sine 60 degree plus 45 degrees, which is equal to, let's fix it now, we're going to have sine 60 degrees cos 45 degrees plus cos 60 degrees sine 45 degrees. Is that true? Yes. Now let's go. In this diagram, what can we say that the value of sine 60 degree is? So when you look closely, you say that sine is equal to opposite all over hypotenuse. And then in this shape, our opposite is root 3. then our hypotenuse is 2. So therefore sine 60. So we ask ourselves a question: what is the value for sine 60 degrees? So from this diagram, you can see that we have opposite all over hypotenuse as sine. Okay, so our opposite is √3, and then our hypotenuse is 2. So therefore sine 60 is equal to √3 all over 2. Okay, yes. And then when we say cos 60, so cos 60, when we look at it very well, we're going to see that cos 60 is equal to 1 all over 2. Okay, that is adjacent all over hypotenuse, and then adjacent is 1, and then hypotenuse is equal to 2. So therefore we have cos 60 degrees is equal to 1 all over 2. Then also when we say cos 45 degrees, so cos 45 degrees is going to give us 1 all over √2. Okay, and then we say that cos 45 degrees is the same as sine 45 degrees. So we're going to have 1 all over √2. So sine 45 degrees is equal to 1 all over √2, and then cos 45 degrees is equal to 1 all over √2, and then sine 60 is equal to √3 all over 2, and then cos 60 is equal to 1 all over 2. Now from here, in this expression, let's fix their true values now. Okay, so that means we're going to say that sine 105 degrees is equal to sine open bracket 60 degree plus 45 degrees, which is equal to sine 60 cos 45 degrees plus cos 60 degrees sine 45 degrees. Okay, now let's fix it properly here now. So what is the value for sine 60? So sine 60 is √3 all over 2. Then times, what is the value for cos 45 degrees? So we have 1 all over √2. So let's place these two terms in a bracket. Then we have plus. So what is the value for cos 60? We say 1 all over 2 times the value for cos 45 degrees, 1 all over √2. Okay, now let's also place this in a bracket. Now in the first bracket, let's multiply. When you say √3 times 1, it's going to give you √3, and then 2 times √2 is equal to 2 √2. Then we have plus. In the second bracket, we have 1 times 1 is equal to 1, and then 2 times √2 is equal to 2 √2. Okay, yes. So we have √3 all over 2 √2 plus 1 all over 2 √2. Okay, yes. In this place now, let's combine them together. Let's combine them, or let's just add them together. So for us to add them together, we're going to look for the LCM. We're going to simply say that the LCM is 2 √2. So 2 √2 divided by 2 √2 is going to give us 1. 1 times √3 is going to give us √3. Then we say plus. So 2 √2 divided by 2 √2 is going to give us 1. 1 times 1 is going to give us 1. So we are going to have √3 plus 1 all over 2 √2. Okay, so we say that sine 105 degrees is equal to √3 plus 1 all over 2 √2. So in this place now, let's rationalize. Okay, so for us to rationalize, we're going to multiply the numerator and the denominator by √2. So that is, we want to remove the √2 in the denominator. Okay, so now let's go. And then you also note that √2 divided by √2 is equal to what? 1. So 1 times our expression, it remains the same. Now let's go. We're going to say √3 plus 1 all over 2 √2 times √2 all over √2. So let's multiply the numerator. We're going to simply say √2 open bracket √3 plus 1 in bracket all over. So when you say 2 √2 times √2, so √2 times √2 is going to give us 2. So 2 times 2, 4. So we're going to have in our denominator 4. So let's use √2 to open the bracket. So when you say root 2 times root 3, it's going to give us root 6. And then root 2 times 1 is going to give us root 2. All over, we have 4. So therefore, sine 105 degrees is equal to root 6 plus root 2 all over 4. Hello? Yes. Let's go. Let's take the last one. Please and please pay attention to this. It's very, very important. Okay, now let's go. We have tan 75 degrees. So what can we say about this 75 degree? What can we do to obtain 75 degree from our special angle? So we can simply say 45 degrees plus 30 degrees. 45 degrees plus 30 degrees is going to give us 75 degrees. But in this case, we say tan what? 75 degrees. And then in one of our formulas, we say that tan A plus B is equal to tan A plus tan B all over 1 minus tan A tan B. Hello? You know, we have tan 45 plus 30. So simply liken it or compare it with tan A plus B, which say that they are the same. Okay, so that means we're going to use the formula tan A plus tan B all over 1 minus tan A tan B to solve this. Okay, good. And then so we're going to use our diagram to find the values for tan 45 degrees and tan 30 degrees. Okay, so because we say less 45 degree represent our A, and then 30 let it be our B. Okay, now let's go. In this diagram, when you say tan 45 degrees, so you know we have opposite all over adjacent. Okay, so tan 45 degrees is going to give us 1 all over 1, which is equal to 1. Okay, good. Now when you say tan 30 degrees, so tan 30 degrees, let's look at this diagram. It's simply going to give us 1 all over root 3. Hello? So tan 30 degrees equal to 1 all over root 3. So we have found the value for A and then B. Alright? Now let's represent it, or let's replace it properly. So we say that tan 75 degrees is equal to tan 45 degrees plus 30 degrees. Okay? So which is equal to tan 45 degrees plus tan 30 degrees all over 1 minus tan 45 tan 30. You get it? Yes. Now, what is the value for tan 45 degrees? The value is equal to 1. Then we say plus tan 30. Tan 30 is 1 all over root 3. You get it? All over. Then we have 1 minus. Let's open the bracket. So tan 45 is 1. Then we have times tan 30. Tan 30 is 1 all over root 3. You get it? Yes. So in our numerator, we have 1 plus 1 all over root 3. So let's combine this together. So we're going to just make use of the LCM. You get it? So let's assume that this one is the same as 1 all over 1. 1 all over 1 is the same as 1. Okay? So let's go. So when we look for the LCM, LCM is going to give us root 3. So root 3 divided by 1 is root 3. Root 3 times 1 is root 3. So we have root 3 plus. In the other side, we have root 3 divided by root 3 is going to give us 1. 1 times 1 is 1. So therefore, in a numerator, when we combine it together, we are going to have root 3 plus 1 all over root 3. Hello? We are going to have root 3 plus 1 all over root 3. Now let's go. In our denominator, we have 1 minus. We have 1 times 1 all over root 3. So let's perform the operation in the bracket. That is, we'll multiply the bracket, okay? The content in the bracket. So we're going to simply say 1 times 1 all over root 3. So it's going to give us 1 all over root 3. So let's remove the bracket. That means it's going to simply have 1 minus 1 all over root 3. So, you know, this 1 minus 1 all over root 3 is almost the same with what we initially have in our numerator, which gives us which gives us root 3 plus 1 all over root 3. So, but the slight difference is that the sign in a numerator is what? Positive, and then this one is negative. So let's join it together. So when we combine this denominator together, it's going to give us root 3 minus 1 all over root 3. Hello. Now that means we are having root 3 plus 1 all over root 3 all over root 3 minus 1 all over root 3. Hello. Yes. Now let's go. This is complex. We can split it into 2. So when we split it into 2, is the same as saying root 3 plus 1 all over root 3 divided by root 3 minus 1 all over root 3. So for us to perform this operation, we're going to change this division sign to multiplication, and then thereby resulting to inversion. That is, a denominator will come up to numerator, and then numerator will come down to denominator in our right hand side. Now let's go. So when we do so, we're going to have root 3 plus 1 all over root 3 times our denominator, which is root 3, will be our numerator now. So we'll have root 3 all over root 3 minus 1. Is that clear? Yes. Now let's multiply. Let's multiply the numerator. We're going to simply say root 3 open bracket root 3 plus 1 all over root 3 open bracket root 3 minus 1. Hello. Yes. So here we have root 3 open bracket root 3 plus 1 all over root 3 open bracket root 3 minus 1. So in this place we have root 3 in a numerator and then in a denominator, and they are outside. So we can simply cancel both of them out. Okay. So when we cancel both of them out, we are left with root 3 plus 1 all over root 3 minus 1. So from here, let's rationalize. Okay. So for us to rationalize, we are going to multiply the numerator and the denominator by root 3 plus 1. Root 3 plus 1, that is the conjugate of the denominator. So we multiply the numerator and the denominator by the conjugate of the denominator. Okay. So and then the conjugate of the denominator is, we simply change the sign. So we have root 3 minus 1. So the conjugate of it is going to give us root 3 plus 1. Okay. Now let's go. So we're going to have root 3 plus 1 all over root 3 minus 1 times the conjugate root 3 plus 1 all over root 3 plus 1. Now let's multiply. In our numerator, we're going to have root 3 plus 1 in bracket times root 3 plus 1 in bracket all over root 3 minus 1 in bracket times root 3 plus 1 in bracket. Okay. Now let's multiply properly in our numerator. So in the first bracket, we have root 3. So root 3 multiply the root 3 in the next bracket, going to give us 3. That is, when you say root 3 times root 3, it's going to give us 3. And then root 3 in the first bracket multiply by 1 in the second, it's going to give us root 3. And then 1 in the first bracket multiply by root 3 in the second bracket is going to give us root 3. And then 1 in the first bracket multiply by 1 in the second bracket is going to give us 1. So in our numerator, we are having 3 plus root 3 plus root 3 plus 1 all over. Let's also multiply our denominator. So we have root 3 in the first bracket multiplied by root 3 in the second bracket. We're going to have 3. Then we have plus root 3 multiplied by 1 in the second bracket. We're going to have root 3. Then we have minus 1 times root 3. It's going to give us minus root 3. And then minus 1 times plus 1 is going to give us minus 1. So in our denominator, we are having 3 plus root 3 minus root 3 minus 1. Okay, good. Now in our numerator, we say 3 plus root 3 plus root 3 plus 1. You get it? Now we say 3 in the first plus 1 at the back is going to give us 4. and then root 3 plus root 3. Simply going to give us something like 2 of root 3. So root 3 plus root 3 is going to give us 2 root 3. Something like orange plus orange is going to give you 2 oranges. Okay, so we have root 3 plus root 3. It's going to give us 2 root 3. So in our numerator, we are having 4 plus 2 root 3. All over. In this place, we have 3 minus 1. So 3 minus 1 is going to give us 2. And then we have root 3 minus root 3. So root 3 minus root 3 is equal to 0. So therefore, in our denominator, we are simply having just 2. So here, we are having 4 plus 2 root 3 all over 2. Okay? Here, what are we going to do? Please and please, pay attention. I want us to split this into 2. So when we split this into 2, we are going to have something like this. 4 all over 2 plus 2 root 2 plus 2 root 3 all over 2. You get it? So when you have something like 4 all over 2 plus 2 root 3 all over 2, when you join this together or when you combine this together, it's going to give you the same thing as 4 plus 2 root 3 all over 2. You get it? Yes. Now let's go. Here we have 4 all over 2. So 4 all over 2, that is 4 divided by 2. It's going to give us what? 2. Is that true? Yes. Now we have plus. In this place we have 2 root 3 all over 2. So we have 2 in our numerator, we have 2 in our denominator. So we can actually cancel out. So when you cancel out, you'll be left with root 3. So here we have 4 divided by 2, which is 2, plus 2 root 3 divided by 2, which is equal to root 3. So therefore, we have 2 plus root 3. So we can see clearly here that tan 75 degrees is equal to 2 plus root 3. Hello. We can see that tan 75 degrees is equal to 2 plus root 3. Is that clear? Yes. Thank you very much for watching. Please, if you have not subscribed to our YouTube channel or you are new to our YouTube channel, please do just subscribe, okay? Please help us and subscribe. And then also remember to click on the bell icon to turn on the notification so that you'll be notified whenever we upload any video. Please comment, like, and share our video. All right? Thank you very much. See you next time.